Welcome back, everyone, to section 1.5, subtraction. So the order of these sections might seem a little bit odd, like why are we doing subtraction after multiplication? That order might seem weird, but there's a reason for it. I do want to go over negation before we did subtraction because it's needed for this new way of understanding subtraction. We're going to change how you likely thought of subtraction prior to this. So we've seen this a lot before. I mean, since probably what, first grade or so, you've been doing subtraction like this, a minus b. So if you have 4 minus 2, what is that really saying? You're taking 2 away from 4, right? And that would be equal to 2. You can also say the difference between 2 and 4 would be 2. That's the way we've always thought of it, and it's not wrong. There's nothing wrong with that, but for a reason that will become clear a little bit later, we're going to alter this definition a little bit. And whenever we see a minus sign, we're going to convert that to addition. And the way that we can convert that to addition is by adding its opposite. So we talked about negation in the last section. So we're going to be adding its negation. So we're going to replace anytime we're doing subtraction, we're going to replace that with adding its negation. Subtracting a number is adding its opposite. So we're going to be doing a lot of converting to this new method. All right, so subtraction again is a combination of addition and negation. So let's test this out. We've got to make sure it works first, because this wouldn't be very useful if this new definition of how we're doing this doesn't actually work. So we know that 9 minus 2 equals 7. You know, that's something that is obvious if you're at the level of taking this course. 9 minus 2 is 7. So if we were to convert it to this new method of doing it, we need to get the same answer. If we don't get the same answer, then we can't do it this way. So let's test this out real quick just to make sure that this new method will give us the same answer. All right, so we have 9 minus 2, but now, like I said, we're going to convert it to adding its negation. So 9 minus 2 is going to become 9 plus the negation of 2, which is negative 2. All right, so now we have it written like this. So let's see if that actually works. So first of all, let's go ahead and do something clever. Like let's split up the 9 into 7 plus 2. We know 7 plus 2 is 9. So these two are equivalent. We could just replace this 9 with 7 plus 2. Nothing wrong with that, right? And so now we have the 7 plus 2 plus negative 2. Now we know that we can use the associative property to regroup. Currently we have these two groupings. The 7 plus 2 is one group, and this negative 2 is another group. But we know we can regroup with the associative property. So instead of having it group this way, let's go ahead and group it this way. We have 7 plus, and now we have a grouping of 2 plus negative 2. Well, 2 plus negative 2, that's exactly what negation is. That's how we explained negation, is a number plus its negation is going to be 0. So we know that this is going to become 7 plus 0, which of course is 7. So we do get the correct answer. Now, of course, this isn't a thorough proof. It doesn't prove that every single case will always work. But if you want, you can try a few. We will be trying a few in the next problems. And again, you can sort of trust me for now that this does in fact work. We could do some more rigorous proofs later, but this does work. So moving on to a little bit more information before we get started with the problems. Another bit of information that you likely already know, but we'll go ahead and be explicit and define it anyways, is that if a plus b equals c, then a is equal to c minus b, right? So if we got to c by adding a and b, that means if we take one of those away from C, we get the other one. So if we take B away from C, then we get A. If we take A away from C, then we get B, because C was the combination of the two. So you take one of them away, and you're left with whatever the other one was. So A equals C minus B, and also B equals C minus A, whichever. If you want A or if you want B, you can both. You can get each of them by just taking the other away from the sum. Another note here is to not confuse negation and subtraction. They both use the same symbol. They both use that minus sign. But if you say like negative 4, that is not subtraction, right? You're not subtracting anything. If you say 4 minus 2, you know, clearly it's the same symbol, but now you're finding the difference between 2 and 4, or you're taking 2 away from 4, which would be 2. But we're using the same symbol for two different things. Again, I know you know this already, but I wanted to just put it out there that these are not the same thing, even though they're using the same symbol. So negation takes one number and returns its opposite. Subtraction takes two numbers and returns their difference. All right. So again, subtraction is the reverse of addition. Since we know that 9 minus 2 is 7, we also know that the blank here in blank plus 2 is going to be 9, right? What do you need to add to 2 to make 9? 7. Another way to do that is to take this number away from 9 to get the first number, because you know that the combination of these two numbers made 9. So you take one of them away and you get the other one. I know I've said that a few times. I kind of just wanted to make sure that that is well understood. There's also a video here. I suggest you go and watch it. I'll put the link in the description below if you just want it worded again in a different way, just to make sure that you have a really clear understanding of that. Okay, jumping right into the problems now, and we're going to use this new understanding, this new definition of subtraction to solve these problems. Again, problems that I'm sure you already know how to solve and you already know the answers to, but let's just try it in this new way. All right, so for the first one, we're going to be converting the subtraction to addition. So we have 0. Now we convert the subtraction to addition, and what do we add? We add the negation of 17. So we add negative 17. And we know that if you add 0 to anything, you just get the same number back. So that's going to be negative 17, because adding 0 doesn't change the number. Okay, so this next one, again, we're going to convert it to addition. So we have 17. Now convert the subtraction to addition. What do we add? We add the negation, negative 17. Again, this is the definition of what negation is. If you have a number and you add its negation, you get 0 back. All right, and then for the last one, also, it's not that we're flipping all the signs, so this would not be careful you're not doing negative 17 plus negative 17. That's not correct. We're only flipping the negative sign, and we're converting this to addition by adding its opposite. So nothing changes with this first number here. Okay, so same thing for this one, 17 plus, and what are we adding here? The negation of 0. What's the negation of 0? Just 0. You could say negative 0 if you want, but we showed a couple sections ago that negative 0 is 0. They're the same thing. And once again, just like this one here, what happens when you add 0 to anything? Nothing. You just get the same thing. So 17 plus 0 is going to be 17. All right, so with those in mind, we can also say that this applies to any other number. If you have 0 minus any number, you're going to get the negation of that number. If you have a number minus that same number, you're going to get 0 back. And if you have a number minus 0, you're always going to get that original number back. Again, things that we already knew, but now we can think of it in this flipped way where we convert it to addition first and add the negation instead of doing the subtraction. All right, same thing for this one. So this one, it doesn't have us solving these yet, but it has us just explaining why these two are equivalent. All right, so we'll start the same way. Actually, I'll give you a second to pause and try it on your own if you like. All right, so let's go ahead and change these to addition. So 11, now this minus becomes plus. And what do we add? So we had negative 13. We want to add the negation of negative 13, which would be 13. We're adding its opposite. And that's what we have here, 11 plus 13. Same thing here. So we have negative 11 here. We're converting. So once again, so I mentioned that negation is not the same thing as subtraction. This is not subtraction. So we're not converting that to addition because it's not subtraction. This is subtraction, so we're converting that to addition. Hope that's clear. All right, so we do convert that to addition, and what do we add? We add the negation of 13, which would be negative 13. So for this one, we can actually show that negative 11 is the same thing as negative 1 times 11. We've done that before. Plus, same thing for negative 13. That's the same thing as negative 1 times positive 13. Okay, so now that we have that, it's very clear that both of these terms have a negative 1 that now we can factor out, or as I like to call it, the reverse of the distributive property. So we can pull that negative 1 outside of some parentheses here, and now we're just left with 11 plus 13. All right, and we don't actually need this 1 here. It doesn't really change anything, so we can just simplify that and write this as negative 11 plus 13. And that's what we have right here. Okay, so for this next one here, we're going to do this a little bit differently. We're going to start from the right side and work backwards. We can start from the left side and work to this, but it ends up doing some things that we haven't quite talked about yet. So it's a little bit more straightforward to start from the right side and work back to the left side based off what we've already talked about. So let's go ahead and do that for this one. So we have this negative 13 plus 11. So we know, just like I just mentioned right here, we can distribute negatives, or in this case, we did the reversal of the distributor property, but we can distribute this negative also, and we've talked about that before. So this becomes negative 13 minus negative 11. Okay, and we also talked about negative of a negative, or subtracting a negative, is going to be a positive. So that becomes negative 13 plus 11. And we also know that addition is commutative. So we can change the order of this because it is addition. And that becomes 11 plus negative 13. And look at that. So we have a plus of a negation, and we know that that's our new definition of subtraction. Subtraction is adding a negation. So we can just convert this back to subtraction again. So now that becomes 11 minus 13. And that's exactly what we're trying to get right here. So if we wanted to do this the other way around, we could start with 11 minus 13. We could change the, well, so we can't change the order of them because subtraction is not commutative. So that's something I hadn't mentioned yet, but subtraction is not commutative. So 11 minus 13 is not the same thing as 13 minus 11. So we cannot swap those. But what we can do is convert that to addition. So 11 plus the negation of 13. And look at that. Addition is commutative, right? So now that it's addition, and this is the whole reason why we did this, by the way. So it's hopefully becoming clear now why we are doing this, is because addition is commutative. And so now we can swap the order of this addition. So now this becomes negative 13 plus 11. And converting it to addition allowed us to do that. All right, so now they're in the right order, right? 13 minus 11. Now it just wants us to kind of extract this negative sign. And this is the part I was talking about that we haven't quite talked about how to do this yet, but we can factor out a negative. And the way that you do that would be to flip the signs of both. This becomes positive 13 plus negative 11. And once again, this plus of a negative here is our new definition of subtraction. So we can just convert that back to subtraction, and this becomes negative 13 minus 11. And that's what we got right here. All right, so here's some more information about the same problem. We can make it a little bit more generic and just say that x minus a negative is the same thing as x plus that second number. So this minus of a negative is going to be the same thing as adding. They cancel each other out. So if you subtract from a negative, then you can extract that negative out and flip the signs, as I mentioned in the last slide. So that x becomes positive, and then this minus becomes plus. So, and you got to make sure you do all terms. So if it was, let's say x or negative x minus y, and let's just say plus z. If you were to extract that negative, you have to make sure you flip the signs of everything. So that would become negative. So that x would be positive. That minus would become plus. And this z, plus y, minus z. Now I did skip a step here. I should have done, minus a negative y to flip the sign of the y. Actually, you know what? Let me just write this out because I think that might be useful to do. So what I should have done when I extracted out this negative sign was flip the signs of everything. So this is a negative x. Remember, I was talking about the difference between negation or negatives versus subtraction. So these two are different. So we're flipping the sign of this x, which becomes positive x. So this y is positive, but we're subtracting. So we're subtracting, and now instead of subtracting a positive y, we're going to subtract a negative y. And then we have our adding of positive z, which now we're going to add negative z, flip the sign of that, right? And so now we can simplify down to this because we know that minus a negative is the same thing as plus, so we can convert that to the plus. And we know that plus a negation is our definition of how we used to define subtraction. So that becomes minus once we convert that back to just regular subtraction. So that's how we got here. All right, and then this last one here, negation of subtraction. Again, when you distribute this negative sign, same thing I just went over. This x becomes negative. This y would become negative, but then minus negative would be plus. And then you can reverse the order of these since its addition is commutative. So then it becomes y minus x. All right, so with all that said, we know that addition and multiplication are commutative. Is subtraction? I already answered that a few times. We know that subtraction is definitely not commutative, which is why we are converting to addition so that we can make it commutative. So again, a video here, link in the description below. I suggest you go and watch that. All right, so next problem, 1.23. Find the numbers a and b such that a minus b is not equal to b minus a. There's a bunch of solutions for this. Let's just kind of pick one at random. So let's say 2 and 1. So if we say 2 minus 1 becomes 2 plus negative 1. And then we can split our 2 into 1 plus 1. So it becomes 1 plus 1 plus negative 1. This here is going to be 0. And we're just left with 1. Again, this is some extra steps. We know that 2 minus 1 is 1. We could have just gotten there straight away. But I want to just have a reminder of how to convert the subtraction to addition. So same thing here. So 1 minus 2, that becomes 1 plus negative 2. We can swap the order here to say negative 2 plus 1. We can extract that negative sign so that the negative sign comes outside the parentheses. We flip the signs, so negative 2 becomes positive 2. Becomes plus negative 1, which ends up becoming just minus 1, right? And from here, we know that 2 minus 1 was 1. So then we get negative 1. All right, so subtraction is not commutative because this is not the same thing as this. So that doesn't work, doesn't come out to the same answer. So that means subtraction is not commutative. We already knew that. I mentioned that a few times. But because we know that since we know that b minus a is equal to negative a minus b, which we just kind of did here, right? We flip the order and then extract the negative sign. We can say that b minus a is the opposite of a minus b. So if we had 2 minus 1, and that was 1, we know that if we flip the order of that, we're actually going to get the negative of our first answer. So is subtraction associative? Can we change the grouping? Let's find out if this works. All right, so let's pick some numbers here for a, b, and c, and see if a minus b minus c is equal to a minus b minus c in parentheses. And it already tells you that it's going to not be equal, so this is not going to be associative. But let's go ahead and show an example of that. So let's try a equals 3, b equals 2, c equals 1. All right, so we'll do 3 minus 2 minus 1, and that's going to be equal to 3 minus 2. We'll skip some steps here. We know how to do subtraction, and I'm sure you got the hang of converting to addition already. So instead of adding the extra steps, you know how to do that. So let's do 3 minus 2. We know is 1. This becomes 1 minus 1, which is 0. All right, that's the first example here. So now let's try this other way. So 3 minus 2 minus 1. The 2 minus 1 becomes 1, and we have 3 minus 1, which is 2. So these are two different answers, which means subtraction is not associative. So we cannot regroup. But it's a little confusing, though, because we know that addition is associative, right? And we know all subtraction is just the reverse of addition. So couldn't we just convert to addition and then make it associative? And in fact, we can. All right, so what's the value of all this stuff? And once again, remember that subtraction is not commutative, so we can't change the order of these. So what do we need to do? Go ahead and give it a shot. All right, let's convert these to subtraction to addition first. So we have our first number here, 1643. That doesn't change. Let's change this first one to addition. So now we have plus negative 1994, and then plus the negative 1643. Well, now we can reorder it because now we're talking about addition. We're talking about adding negatives instead of subtraction. So let's go ahead and write it like this: 1643 plus negative 1643, and we know that that is how we do negation. That is going to be 0. And then we're going to be left with this negative 1944, because 0 plus negative 1944, well, adding 0 to anything is just whatever you're left with. So that's negative 1994. All right, so let's try another one. Go ahead and pause it and give it a shot. Notice here we have some addition and subtraction here. So for this one here, let's just try to make it as easy as possible on ourselves. So we don't have anything that perfectly cancels out, but if you take a look at those, that's pretty close. That would be a nice, easy subtraction to do. Right here, again, that's a nice, easy subtraction to do. And this one here, have a lot of common numbers there. So let's give that a shot. So let's convert them all to addition. So that's what I did here. We know how to do this by now. Then let's go ahead and group the similar numbers together. So I brought the 268 next to the negative 168, the 1375 plus the negative 1275, and the 6179 with the negative 6079. So this is going to be 100 right there. So we can convert that back to subtraction now, because thinking about it in terms of subtraction now might be a little bit simpler. 268 minus 168 is going to be 100. 1375 minus 1275, that's 100. And 6179 minus 6079 is another 100. So we have 3 100ths to be 300. With enough practice, you're not going to need to convert these to addition and then back to subtraction again. But know that you need to bring this sign with you wherever it goes. So you can't leave that minus and then just bring the 168 to, let's say, right here. You can't make this 168 plus 268. Obviously, that's not how it would work, and you would get the wrong answer if you did that. So you need to make sure that you bring that negation with you, because you know that this minus becomes plus the negation, right? So you got to make sure you bring that negation along with you. All right, so let's do another one. Explain why 26 minus 24 times 64 is equal to this right side, and then go ahead and compute it. So give that a shot. All right, so we know how the distributive property works, but we usually use it with addition, and this is with subtraction. Do we know if the distributive property works with subtraction? I haven't talked about that yet, so instead, let's go ahead and convert it to addition, because we know it works with addition. So let's go ahead and just do that. Let's convert it. So that this here becomes 26 plus negative 24, and that's times 64. Now we know we can distribute the 64. Maybe we could before, maybe we couldn't. We don't really know, but now we know we can. So now it becomes 26 times 64 plus negative 24 times 64. And now we see that we have the adding a negative here. So that is our definition of subtraction. This is our new definition of subtraction. So now we can convert that back to just standard minus sign. So now we have 26 times 64 minus 24 times 64, which is what we're looking for right here. And now we can compute that. And we also can see that actually the left side of this is easier to compute. So let's go ahead and compute this one. We know that they're the same, so we can compute either one. If we wanted to do it this way, we could, and we get the right answer. But we know that these are going to be the same. They're equivalent to each other. And this one's just easier to solve. This is going to be 2. 26 minus 24 is 2. Times 64, we know, is 128. All right, so multiplication does, in fact, distribute over subtraction. So if we have a times the quantity B minus C, then that becomes AB minus AC. Same thing with if the outer number, the multiplication is on the right side, it can still distribute across from the right side or the left side, it doesn't matter. All right, on to the next one. Use the fact that 999 equals 1,000 minus 1 to evaluate that. I'll give you a second to do that. This is a big hint right here. 999 is equal to 1,000 minus 1. All right, so we know we can distribute with subtraction. So we know that 999 is the same thing as 1,000 minus 1. So we just plug this in for right here. And then we have 1,000 minus 1 times 345, and now we know we can distribute that. That becomes 345,000 minus 345. And if you were to do that subtraction real quick, you would get 344,655. All right, and that's it for subtraction. Hopefully that all made sense. Please leave a comment if you have any questions. I'm happy to explain anything. Remember to like, subscribe, and yeah, follow along if you continue to enjoy the series, if it's helpful. And also do these 1.5 exercises in your textbook. Super helpful. See you guys next time.